On screen, we can see a pressure gauge whose manufacturer specifies that it is suitable for use with R32 refrigerant. This means that the instrument is built to withstand the characteristic pressures of this gas and provides adequate accuracy within the working range of R32. In addition to the pressure scale, this type of gauge includes a temperature scale, which serves a function similar to that of a thermodynamic property table for the gas. This scale allows us to know the temperature of the refrigerant at its saturation point, meaning when it is in both liquid and vapor state at the same time. This condition, fundamental in thermodynamics, is known as saturation temperature. Understanding this concept is essential because within the coils of the indoor and outdoor units of the air conditioner, the refrigerant is precisely in this saturation condition during the heat transfer process. In this video, we will see the use of the R32 gauge to observe its pressures and saturation temperatures in air conditioning units, and we will study some faults detected with this gauge. A. When the air conditioning unit is turned off, the gauges will display the same pressure on both the high side and the low side of the system. This happens because there is no active circulation of refrigerant. The compressor does not suction or discharge gas, allowing the system to reach a state of equilibrium, reflecting only the static pressure of the refrigerant inside. Since the compressor is not operating, the value of this pressure will depend directly on the outdoor ambient temperature. For example, at an ambient temperature of 30 degrees Celsius, about 80 degrees Fahrenheit, the gauges will indicate a pressure of around 260 pounds per square inch, which corresponds to the equilibrium gauge pressure. B. When the air conditioning unit is operating, the compressor suctions refrigerant from the evaporator or coil of the indoor unit, thereby generating low pressure. Then the compressor discharges the refrigerant and sends it to the condenser or coil of the outdoor unit, where the accumulated and condensed gas finally generates high pressure. The required low pressure will depend on the function of the system. For example, in a conventional air conditioner, the temperature is maintained above 0 degrees Celsius 32 degrees Fahrenheit, since the evaporator coil is not intended to freeze. If we look at a gauge for R32 refrigerant, for example, a saturation temperature of 4 degrees Celsius, about 40 degrees Fahrenheit, corresponds to an approximate pressure of 120 pounds per square inch. C. On the other hand, to estimate the normal high side pressure, the ambient temperature is taken as reference and a differential of approximately 10 degrees Celsius 18 degrees Fahrenheit is added. Thus, for an ambient temperature of 30 degrees Celsius 86 degrees Fahrenheit, adding a differential of 10 degrees Celsius 18 degrees Fahrenheit results in a condensation temperature of 40 degrees Celsius 104 degrees Fahrenheit, which translates to a high side pressure close to 345 pounds per square inch. Now let us study some faults detected with gauges. A. When there is an evaporator coil freezing issue and the temperature drops below 0 degrees Celsius 32 degrees Fahrenheit, the expected low side pressure is below 100 pounds per square inch. B. When there is a deficiency in heat exchange of the condenser, the high side or condenser pressure is much higher than normal. For example, at an ambient temperature of 30 degrees Celsius 86 degrees Fahrenheit, due to this fault, the high side pressure is expected to be much greater than 345 pounds per square inch, indicating a symptom of this problem. C. When the needle of the low side gauge vibrates or oscillates, it may be a sign of moisture problems inside the pipes, or it may indicate mechanical failures of the compressor, or a partial blockage of the capillary tube or filter. D. When some time after turning on the unit, the low side pressure of the gauge drops noticeably and remains consistently very low, and the high side pressure tends to rise although it later stabilizes, it may be a sign of a severe blockage of the capillary tube or filter dryer. E. If once the unit is turned on, the pressure on both gauges is lower than normal, it may be a sign of a refrigerant gas leak. This can be confirmed if the electrical consumption is much lower than normal. F. If the compressor starts, but there is no clear difference between the low and high pressure, it is a sign of mechanical problems in the compressor.